2.1. And as I solve this question 7 on 2.1, I also want to give you some general approaches on what you do when you have proof type problems. Okay, so what are you trying to show? You're trying to show that the sample correlation between y and y hat is equal to r square root of it. Every time you're going to get a proof problem, the way I'd like to start, almost all of them, is I like to think of this as my left-hand side. Okay, left-hand side equation, and I'm going to have a right-hand side equation. And of course, the general approach would be you either try to go from the left-hand side to the right-hand side, or you go from the right-hand side to the left-hand side. Both ways are equally valid to show that those two things are equivalent, okay? But in that process, you need to do manipulation. Here's step 1 that everybody should be able to do. If you don't know how to do step 1, you are hopeless at solving this. What is step 1? Is to rewrite the left-hand side and the right-hand side using the definitions. If you don't know that, there's no way you can prove it, okay? So what's the sample correlation? Let me try to use different color for this. So sample correlation, so correlation of y and y hat will simply be equal to the sum y minus y bar, y hat minus y hat bar, divided by the sample standard deviations of these two things. So I'm going to have sum of y minus y bar squared times sum of y hat minus y hat bar squared. That's my left-hand side, and I've purposefully written it with a very common mistake that students make. What is the common mistake when you look at that left-hand side? Done a mistake there, which is a very serious mistake in some sense.
You're missing the eyes.
Of course, I'm missing the eyes. You don't know what's changing in that summation notation, okay? It's going to be important. It's also going to be important for you to know what are the things that are going to change when I change each term. So I'm going to try and do that with a different color. I need a yi here. I need a y hat I here. I. And of course I'm being lazy. Every time I see a summation notation, I could have of course said from 1 to n. But I'm being lazy, and I think it's okay to be that lazy, okay? As long as it's between I and n, there's no special summation, that's okay. What's gonna be my right-hand side? Let's do it in green. Well, I need to know the definition of it. It's gonna be the explained sum of square, sum of yi hat minus y bar squared over sum of yi minus y bar, all of this squared. That's my right-hand side. What's my goal to prove this? Go from either the left-hand side to the right-hand side, or from the right-hand side to the left-hand side. I'm going to choose to try and go from the left-hand side to the right-hand side. Okay, that's my sort of like my goal. Now, what students find a little bit uneasy with proofs is that they say, well, Revi, I couldn't really do this on my own. Okay, I kind of had to watch the videos. And I say, well, that's okay, as long as you can, in 3 days after you watch the video, you can replicate that and you've understood all the steps. That's okay. But let's try and build some muscle on how you could have done that on your own without necessarily just replicating something that someone has done. What differences do you notice between the right-hand side and the left-hand side that you might want to get rid of? What is something that the left-hand side has but the right-hand side doesn't have, for example? Yeah.
Y hat.
Yes, if I look at this denominator, if I look at the numerator, for example, let's focus on the numerator for a second. Right? Here, on the numerator of this, I don't see any yi's, okay? There's no yi's on the on that numerator over there. So possibly you might say, well, maybe one possible way is to try and you know, maybe rearrange that. What's another thing that you notice? What's another thing that you notice on the left-hand side that's not on the right-hand side? What's one thing that you notice that's not, it is on the left-hand side, but it's not on the right-hand side? Yeah.
The Y bar hat.
The Y bar hat or the Y hat bar. So I'm going to have to make some progress here, and I'm going to try and make progress here by just saying, well, actually, I know that Y hat bar is the same thing as Y bar by mechanical property. That one step is going to make that left-hand side look a little bit more familiar to the right-hand side, because the right-hand side doesn't have any Y hat bars. Okay, so that's my first thing I'm going to do. I'm using mechanical property. I'm telling my examiners that's what I'm using as I go to that step. Okay, I look at the numerator and I look at the numerator of this and I look at the numerator of this. They don't quite look the same. Perhaps one possible way that I could go about it is that the numerator in the right-hand side doesn't have any yi's. Okay, the numerator on the right-hand side doesn't have any yi's. So what possible candidates are there for me to replace this yi? What could I replace that yi with? Yeah.
N times y bar.
You got to be a bit careful here. The sum, it's true that the sum of the yi's could be replaced as n times y bar. And that could be a good start, okay? You could say, well, actually, that's one possible option. I could do that, right? Here's the problem that, and you should try and do that, right? You should try and do that and see if it will lead you anywhere. But in order to get a summation, notation, you're going to have to multiply this summation notation with this other bracket here as well, okay? So you're going to have yi times yi hat, sum of that, and you're not going to be able to use this, okay? So unfortunately, y is a good start to kind of say that. You'll realize that you're not going to fully get rid of the yi, right? You're not going to be able to get rid of the yi, but it's a good starting point. What's another possibility that I could have?
You multiply it out.
I could multiply it out, but I really want to get rid of it. I really want something else for it that would make those numerators maybe look a little bit more alike. Of course, yi could be written as yi hat plus epsilon I hat. Okay, so let me try and do that here by kind of like almost cheating here a little bit. I try and get rid of this. And what I'm going to do here is I'm just simply going to write yi hat plus epsilon I hat. Agree? And then the top part of that, I can rewrite it as, see if you can follow this manipulation here. Top part of that, I can simply rewrite it as, get rid of this epsilon I and multiply it out. So just simply add it here to be plus sum epsilon I hat yi hat minus y bar. Everybody can follow that? Can you all follow that bit over there? Now, if you've done the in-lecture exercises or looked at the videos that we did, you know that we have proven from mechanical properties here, this whole thing will equal to what? By the fact that the sum of this is equal to 0 and the sum of epsilon I xi is also equal to 0. So this whole thing is equal to 0. Oh, okay, well, it's starting to look a bit more familiar. So now my left-hand side looks like this. Now, let me give you 1 minute. See if you can now get some practice and a bit of thinking in there. How could I go now from the left-hand side to the right-hand side? Have I made any progress? Have I gotten a bit closer? And is there a transformation that I can do to the left-hand side for it to look more like the right-hand side? Let's compare numerators. Let's compare denominators. See if you can join groups, maybe in groups of 2, not more than 2. See if you can try and see if you can make that jump from the left-hand side to the right-hand side. See if you can do that very quickly. And if you're watching the video, just do the same thing. So try to think, how could the left-hand side be the same as the right-hand side? What could I manipulate? How could I manipulate the left-hand side without changing it, right? What kind of manipulation can I do? I could divide and multiply both numerator and denominator by the same thing, right? For example, right? I could do manipulation. So what can you do? See if you can think about that.
Like if you have this expression, it's like a variable or something, it's like 7 to the first power. And this is like that to this half power. So if you like manipulate that, then it's like this to the 1/2 power on the residual. And then the denominator is it.
And then probably
And then the same thing at the bottom, like what we did with the y hat, as well as like the epsilon term plus whatever. You can do that and get the 0. So the numerator, like, and then the first part of the denominator, that's like the same term. So if you like cancel that out, if you break up the square root into like 2 parts, then you have like something to the first power, and then that thing the half power. So like, yeah, like this and this ends up just being like this term to the half power of the numerator. So, and that's the numerator we have. And then right side.
Ravi, can you please write the little purple thing a little neater?
It's just mechanical properties, right?
Okay.
Now, of course, if you didn't understand that bit, why is that is equal to 0, you just have to go to a different video, okay? To really understand why that thing is equal to 0 means that there's something there that you need to kind of practice on. Anyone figured it out? How I can go from this left-hand side to the right-hand side? Can I hear it? Yeah?
Well, if we sort of, by the same logic that we used in the numerator, we substitute the yi hat for the yi plus the residual, maybe?
If we substitute the which one? The yi?
The yi hat
Uh-huh.
for the yi plus the residual.
The yi hat. Well, we gotta be big careful here because we're gonna have a residual there. That's not necessarily anymore going to be 0, right? We're not going to be able to do. But it's a good time to start.
You divide top and bottom by same above and bottom, so sum of yi hat minus y bar squared.
Yeah, I can. Can divide both sides by something. But look at this, right? If you look at this denominator here, does it have any y hats? No, it doesn't. Okay. If you look at this, it's kind of looking similar to this, but it's just the square root of this, right? But look, this term here is the same as this term here. Agree? They're the same. So I could just have rewritten this as, let's cheat. There's nothing that prevents me to rewrite this as 2 separate square roots. Agree? What's the square root of something is the same thing as raising something to the power of a half. So this is to the power of 1. The denominator is to the power of a half. How could I simplify those two things together? By just writing something to the power of a 1/2. The numerator, now I can delete this, and I can make the numerator be to the power of 1/2. But what is that?
Square root.
That's square root. So what do I have? I have square root, taking the square root of sum yi minus y bar squared over sum of yi minus y bar squared. This is a hat here, right? Let's not forget the hat. Let me just make this a little bit neater. yi hat minus y bar squared. But what's on the inside? What's the inside? This thing here is explained sum of square. This thing here is total sum of square. So what do we have? Exactly the right hand side. I proved it. I went from the left hand side to the right hand side. Let's summarize how we did it, what the big picture was. The big picture was step one. Does the student know the definition of the left hand side and the right hand side? Can they write out what those expressions are? We did that. Then the next bits were, does the student understand mechanical properties well enough to manipulate one side to get into the other side? And does the student understand the properties of summation notations well enough to do those manipulations? And in that process, you're constantly checking. Check the numerator, check the denominator. Are they similar? Are they different? What can I do to make them a little bit more similar, a little bit more different? And if you can't make it, it's okay. Try to then learn the method of someone, right? But then as you learn that method, ask yourself, can I use this method somewhere else? Can I blend whatever I did here to a different, to a different groove or to a different thing? So that's what I have for this bit.